National Electrical Code Article 820.93 addresses the specific issue of installing service equipment on structures used for supporting overhead conductors. This code section is crucial for maintaining electrical safety and preventing potential hazards associated with improper installations. The primary focus of Article 820.93 is to prohibit the installation of service equipment on poles or other structures that are already used to support overhead electrical conductors. This prohibition is in place to ensure that the structural integrity of the pole is not compromised. Adding equipment such as a satellite dish increases the load on the pole and subjects it to additional wind and ice loading. This can lead to premature failure of the pole. The electrical safety risks include the potential for electrical interference between the satellite dish and the power lines, which can cause equipment malfunction or even electrocution. Moreover, unauthorized attachments to power poles can create safety hazards for utility workers who maintain the electrical infrastructure. Such attachments may obstruct access to the equipment or create unexpected electrical pathways. The code specifically targets service equipment. Service equipment refers to the equipment necessary to deliver electricity from the serving utility to the premises being served. This typically includes items such as service disconnects, overcurrent protection devices, and metering equipment. However, the principle extends to other equipment that could pose similar risks. By prohibiting the installation of service equipment on poles supporting overhead conductors, the code aims to prevent several potential problems. Firstly, it minimizes the risk of structural overload. Power poles are designed to withstand specific loads, including the weight of the conductors, insulators, and other necessary hardware. Adding extra weight from service equipment can exceed the pole's design capacity, especially under adverse weather conditions such as high winds or heavy ice accumulation. Secondly, the code helps to maintain the reliability of the electrical system. If a pole fails due to excessive load or improper installation of equipment, it can lead to power outages and disruptions in service for customers in the area. By preventing such failures, the code contributes to a more stable and dependable power supply. Thirdly, the code enhances safety for both utility workers and the general public. Unauthorized attachments to power poles can create hazardous conditions for workers who need to climb and maintain the poles. Additionally, if equipment is improperly installed, it can pose a risk of electrical shock or other injuries to people who come into contact with it. From a practical standpoint, the enforcement of Article 820.93 involves several steps. Utility companies typically have policies in place to inspect and monitor their poles for unauthorized attachments. If a violation is discovered, the utility will usually notify the property owner and require them to remove the equipment. Failure to comply with the removal request can result in further action, such as disconnection of service or legal proceedings. In addition to the utility companies, local electrical inspectors also play a role in enforcing the NEC. During inspections of new or existing electrical installations, inspectors will verify that service equipment is properly installed and that no violations of Article 820.93 exist. It is important to understand that the NEC is not a law in itself, but rather a set of guidelines and standards that are adopted by state and local jurisdictions. When a jurisdiction adopts the NEC, it becomes legally binding and enforceable within that area. Therefore, it is essential for electrical contractors, property owners, and other stakeholders to be familiar with the NEC requirements in their specific location. Furthermore, other relevant sections of the NEC may provide additional context and requirements related to the installation of service equipment and the use of power poles. It is always a good practice to consult with a qualified electrical professional to ensure full compliance with all applicable codes and standards. In summary, National Electrical Code Article 820.93 is a critical provision that prohibits the installation of service equipment on poles or other structures used for supporting overhead conductors. This code is designed to prevent structural overloads, maintain the reliability of the electrical system, and enhance safety for utility workers and the public. By adhering to this code, we can ensure that electrical installations are performed in a safe and responsible manner. In addition to the points already mentioned, there are several other considerations related to the installation of satellite dishes and other equipment on or near power poles. These considerations are important for ensuring the safety and reliability of the electrical system and for preventing potential hazards. One key factor is the clearance requirements between electrical conductors and other objects. The NEC specifies minimum clearances that must be maintained between overhead power lines and buildings, trees, and other structures. These clearances are designed to prevent accidental contact with the conductors, which could result in electrical shock or fire. When installing a satellite dish or other equipment near a power pole, it is essential to ensure that these clearance requirements are met. This may involve relocating the equipment or installing barriers to prevent it from coming too close to the conductors. Another important consideration is the potential for electromagnetic interference (EMI). Power lines can generate electromagnetic fields that can interfere with the operation of electronic equipment, including satellite dishes. This interference can cause poor signal quality or even complete loss of signal. To minimize the risk of EMI, it is advisable to locate the satellite dish as far away from the power lines as possible. Shielded cables and other techniques can also be used to reduce the effects of EMI. Furthermore, it is crucial to ensure that any equipment installed on or near a power pole is properly grounded. Grounding provides a path for electrical current to flow safely to the ground in the event of a fault. This helps to prevent electrical shock and reduce the risk of fire. The NEC specifies detailed requirements for grounding electrical systems and equipment. These requirements must be followed carefully to ensure that the grounding system is effective. In addition to the NEC requirements, local utility companies may have their own rules and regulations regarding the installation of equipment on or near power poles. These rules may address issues such as access to the poles, restrictions on the types of equipment that can be installed, and requirements for obtaining permits or approvals. It is important to contact the local utility company to determine what rules apply in your area. It is also worth noting that attaching a satellite dish or other equipment to a power pole without permission can be considered trespassing or vandalism. This can result in legal penalties, including fines and even imprisonment. Therefore, it is always essential to obtain the necessary permits and approvals before installing any equipment on or near a power pole. In summary, the installation of satellite dishes and other equipment on or near power poles is subject to a variety of regulations and requirements. These regulations are designed to ensure the safety and reliability of the electrical system and to prevent potential hazards. It is crucial to be familiar with the NEC requirements, local utility company rules, and any other applicable regulations before undertaking such an installation. Consulting with a qualified electrical professional is always a good idea to ensure that the installation is performed safely and in compliance with all applicable codes and standards. Now let's consider some specific scenarios and how the NEC and other regulations would apply. Firstly, imagine a situation where a homeowner decides to install a satellite dish on a power pole located on their property. The homeowner believes that this is the best location for the dish because it provides an unobstructed view of the sky. However, the homeowner has not obtained permission from the utility company or consulted with an electrical professional. In this scenario, the homeowner is likely in violation of several regulations. As discussed earlier, NEC Article 820.93 prohibits the installation of service equipment on poles supporting overhead conductors. A satellite dish would likely be considered service equipment in this context. Additionally, the homeowner may be in violation of local utility company rules regarding unauthorized attachments to power poles. The utility company could require the homeowner to remove the satellite dish and could impose penalties for the unauthorized installation. Furthermore, the homeowner could be held liable for any damages or injuries that result from the improper installation. For example, if the satellite dish were to fall off the pole and damage a neighboring property, the homeowner could be sued for the cost of repairs. Now consider a different scenario where a commercial business wants to install a wireless communication antenna on a power pole. The business has obtained permission from the utility company and has hired a qualified electrical contractor to perform the installation. In this case, the installation would likely be permissible, provided that certain conditions are met. The electrical contractor would need to ensure that the installation complies with all applicable NEC requirements, including those related to clearance, grounding, and wiring methods. The contractor would also need to ensure that the installation does not overload the power pole or create any other safety hazards. Additionally, the utility company may impose specific requirements for the installation, such as the use of particular types of hardware or the placement of warning signs. It is important to note that even with permission from the utility company, the installation may still be subject to local zoning regulations or other requirements. The business would need to obtain any necessary permits or approvals before proceeding with the installation. Finally, let's consider a scenario where a utility company needs to install new equipment on a power pole. In this case, the utility company would be responsible for ensuring that the installation complies with all applicable NEC requirements and other regulations. The utility company would also need to take steps to minimize any disruption to service during the installation process. This may involve scheduling the work during off-peak hours or providing temporary power to customers in the area. In all of these scenarios, it is crucial to prioritize safety and to follow all applicable regulations. Improper installations can create significant hazards and can result in serious consequences. Consulting with a qualified electrical professional is always a good idea to ensure that the installation is performed safely and in compliance with all applicable codes and standards. To further illustrate the importance of adhering to the NEC and local regulations, let's delve into some specific examples of potential hazards that can arise from improper installations on or near power poles. Firstly, consider the risk of electrical shock. Power lines carry high voltages, and contact with these lines can be fatal. Improperly installed equipment can create pathways for electrical current to flow to ground, increasing the risk of electrical shock. For example, if a satellite dish is not properly grounded, it could become energized in the event of a fault. Anyone who touches the dish could then receive a severe electrical shock. Secondly, consider the risk of fire. Electrical faults can generate heat, which can ignite nearby combustible materials. If a satellite dish is installed too close to power lines, an electrical fault could cause a fire. This fire could spread to the power pole itself, potentially causing it to collapse. Thirdly, consider the risk of structural failure. Power poles are designed to withstand specific loads, including the weight of the conductors, insulators, and other necessary hardware. Adding extra weight from improperly installed equipment can overload the pole, especially under adverse weather conditions. This overload can cause the pole to lean, crack, or even collapse. A collapsing power pole can damage nearby property and can create a serious safety hazard. Fourthly, consider the risk of service disruption. Improper installations can interfere with the operation of the electrical system, leading to power outages and other disruptions in service. For example, if a satellite dish is installed too close to power lines, it could cause electromagnetic interference, which can disrupt the flow of electricity. In addition to these direct hazards, improper installations can also create indirect risks. For example, if a satellite dish is installed without permission, it could obstruct access to the power pole for utility workers. This could delay repairs and prolong service disruptions. In light of these potential hazards, it is clear that proper installation practices are essential. These practices include following all applicable NEC requirements, obtaining necessary permits and approvals, and consulting with qualified electrical professionals. By taking these steps, we can minimize the risk of accidents and ensure the safety and reliability of the electrical system. Now let's shift our focus to some of the specific requirements outlined in the NEC that are relevant to the installation of equipment on or near power poles. One important requirement is the need for proper grounding. The NEC specifies detailed requirements for grounding electrical systems and equipment. These requirements are designed to ensure that there is a safe path for electrical current to flow to ground in the event of a fault. In the case of a satellite dish or other equipment installed on or near a power pole, it is essential to ensure that the equipment is properly grounded. This typically involves connecting the equipment to a grounding electrode, such as a ground rod or a metal water pipe. The grounding conductor must be sized appropriately for the equipment and must be installed in accordance with the NEC requirements. Another important requirement is the need for proper clearance. The NEC specifies minimum clearances that must be maintained between electrical conductors and other objects. These clearances are designed to prevent accidental contact with the conductors, which could result in electrical shock or fire. When installing a satellite dish or other equipment near a power pole, it is essential to ensure that these clearance requirements are met. This may involve relocating the equipment or installing barriers to prevent it from coming too close to the conductors. The NEC also includes requirements for wiring methods. The NEC specifies the types of wiring that can be used in various applications. When installing a satellite dish or other equipment on or near a power pole, it is essential to use wiring that is appropriate for the environment and that is installed in accordance with the NEC requirements. This may involve using weatherproof wiring or installing the wiring in conduit to protect it from damage. In addition to these specific requirements, the NEC also includes general requirements for electrical safety. These requirements cover a wide range of topics, including the use of approved equipment, the proper installation of electrical components, and the need for regular maintenance and inspections. By following all of the requirements in the NEC, we can ensure that electrical installations are performed in a safe and responsible manner. To further enhance safety, it is also important to consider the use of personal protective equipment (PPE). PPE includes items such as rubber gloves, safety glasses, and hard hats. When working on or near power poles, it is essential to wear appropriate PPE to protect against electrical shock, falls, and other hazards. Finally, it is important to emphasize the need for ongoing education and training. The electrical industry is constantly evolving, and new technologies and regulations are being developed all the time. To stay up to date, it is essential for electrical professionals to participate in ongoing education and training. This can help them to improve their skills, learn about new technologies, and stay informed about the latest NEC requirements. In conclusion, the installation of equipment on or near power poles is a complex and potentially hazardous task. By following all applicable regulations, using proper installation practices, and prioritizing safety, we can minimize the risk of accidents and ensure the reliability of the electrical system. Remember to consult with qualified electrical professionals and stay informed about the latest developments in the electrical industry. As technology evolves, so do the methods and materials used in electrical installations. Staying current with these advancements is vital for ensuring safety and efficiency. For example, new types of insulation materials offer improved protection against electrical faults and environmental factors. Similarly, advancements in grounding techniques provide more effective pathways for fault currents, reducing the risk of electrical shock. Another area of innovation is in the development of smart grid technologies. These technologies enable more efficient monitoring and control of the electrical grid, helping to prevent outages and improve overall system reliability. As smart grid technologies become more widespread, it will be increasingly important for electrical professionals to understand how they work and how to install and maintain them properly. In addition to technological advancements, there are also ongoing efforts to improve electrical safety standards and regulations. The NEC is updated every 3 years to reflect the latest knowledge and best practices in the electrical industry. These updates often include new requirements for grounding, wiring methods, and other aspects of electrical installations. It is essential for electrical professionals to stay informed about these updates and to incorporate them into their work. Furthermore, there is a growing emphasis on sustainability in the electrical industry. This includes efforts to reduce energy consumption, promote the use of renewable energy sources, and minimize the environmental impact of electrical installations. As sustainability becomes more important, electrical professionals will need to develop new skills and knowledge related to energy efficiency, renewable energy technologies, and green building practices. In summary, the electrical industry is a dynamic and evolving field. To succeed in this industry, it is essential to stay current with the latest technological advancements, safety standards, and sustainability practices. By embracing lifelong learning and continuous improvement, electrical professionals can help to ensure the safety, reliability, and sustainability of the electrical system. Let's consider some specific examples of how these trends are impacting the installation of equipment on or near power poles. For example, the increasing use of wireless communication technologies is driving the demand for the installation of antennas on power poles. These antennas are used to provide wireless internet access, cellular service, and other communication services. However, the installation of these antennas must be done carefully to ensure that it does not compromise the safety or reliability of the electrical system. The NEC includes specific requirements for the installation of communication equipment on or near power poles. These requirements address issues such as clearance, grounding, and wiring methods. It is essential for electrical professionals to follow these requirements carefully to prevent accidents and ensure that the antennas operate properly. Another example is the growing use of LED lighting. LED lighting is more energy efficient than traditional lighting, and it is becoming increasingly popular for street lighting and other outdoor applications. However, the installation of LED lighting on power poles must be done in accordance with the NEC requirements. The NEC includes specific requirements for the wiring and grounding of LED lighting fixtures. It is essential for electrical professionals to follow these requirements to prevent electrical shocks and ensure that the lighting operates properly. Finally, the increasing use of renewable energy sources is also impacting the installation of equipment on or near power poles. For example, solar panels are often installed on power poles to provide electricity for street lighting or other applications. The installation of these solar panels must be done in accordance with the NEC requirements. The NEC includes specific requirements for the wiring and grounding of solar panels. It is essential for electrical professionals to follow these requirements to prevent electrical shocks and ensure that the solar panels operate properly. In all of these examples, it is clear that staying current with the latest technological advancements and NEC requirements is essential for electrical professionals. By doing so, they can ensure that electrical installations are performed safely, reliably, and sustainably. To further emphasize the importance of these issues, let's consider some potential consequences of failing to follow proper installation practices. For example, if a wireless communication antenna is not properly grounded, it could become energized in the event of a fault. This could create a serious electrical shock hazard for anyone who comes into contact with the antenna. Similarly, if LED lighting fixtures are not properly wired, they could overheat and cause a fire. This could damage the power pole and could create a safety hazard for people in the area. Furthermore, if solar panels are not properly installed, they could cause damage to the electrical system or could create a fire hazard. In addition to these direct consequences, improper installations can also lead to indirect problems. For example, if a power pole is damaged due to an improper installation, it could cause a power outage for a large area. This could disrupt businesses, schools, and other essential services. Similarly, if a communication antenna is not properly installed, it could interfere with wireless communication signals, causing problems for cellular phone users and other wireless devices. In light of these potential consequences, it is clear that proper installation practices are essential. Electrical professionals must take their responsibilities seriously and must follow all applicable regulations and standards. By doing so, they can help to ensure the safety, reliability, and sustainability of the electrical system.